All right, here's lesson three for radicals. Good morning, Delilah, Danny, and Kenneth. Hopefully you're enjoying Alaska, sailing amongst the fjords. Um, we're still on the same chapter. There's two more kind of topics on radicals I want to cover in this lesson, and then we'll do one more, a fourth lesson during this week. I know it's Friday already. I'm going to do one more probably tomorrow, just to start us off with quadratics. So we're still on radicals. Let me get to the page. It's page 104. That's where we're going to start. And let me start sharing my screen. Okay, a little too small. Let's zoom in here. And there we go. Now we can read it. Okay, so in the last lesson, we covered the operations with radicals. We added, we subtracted, we multiplied, and divided. Part of the dividing process is called rationalizing. And that happens if we get a result that has the radical symbol in the denominator. Um, we don't want to end up with an answer with a radical in the denominator. There's some reasons for that that apply mainly to other applied versions of math, but at least in the algebra stage of your math careers, we're going to practice getting the radical symbol out of the denominator. And so far, we've practiced that in examples like this. Let me get this pen ready to go. Um, for example, if we had something like um, the here, well, I'll just use the example in the book here. Square square root of 5 over 2. That's equivalent, of course, we know by now that of square root of 5 over the square root of 2. Now there's a radical in the denominator there. We don't want that for some reason or another. So what we're going to do is multiply the entire fraction, top and bottom, by whatever that denominator is, right? This is called rationalizing. And when we do that, we'll get a result that no longer has a radical in the denominator, right? Square root of 2 times the square root of 2 is just 2. Now, up top, we'll have the square root of 10, and that's fine. So this, no more radical. See, no radical in the denominator. Now, that's fine and good. Every example we've done so far has involved a monomial in the denominator. That means there's just one term. But what are we going to do if we get a problem, say, like this? Square root of 5 over 1 plus the square root of 2. Hmm. Well, your first inclination might be, oh, we can just do the same thing, right? Let's just multiply the top and bottom by the exact same thing. But this will actually not get rid of the radical in the denominator. What we would have to do is FOIL this out, right? And we would actually get 1 plus 2 times the square root of 2 plus 2, which of course we can write as 3 plus 2 times the square root of 2. There's still a radical there, okay? So we can't use the same exact process, but we're going to do something slightly different. So let me erase this. What we're going to do is multiply not by the exact same thing, but by something called the conjugate of the denominator. The conjugate of a binomial is the exact same two terms, right? A 1 and a square root of 2. 1 and a square root of 2. But instead of a plus, we're going to use the opposite sign, a minus. Because now look what happens when we FOIL out the bottom here. We'll get 1. We'll get plus the square root of 2, sorry, minus the square root of 2 minus the square root of 2 plus the square root of 2 minus 2, right? Hopefully you can see I just FOILed those four out. And what happens is the two middle terms will cancel, leaving us with 1 minus 2, which of course is just negative 1. Now we have no radical in the denominator. Now we still have to multiply the numerator. And here where it's going to involve some distribution, right? So we got to multiply that and that. And we'll get square root of 5 minus the square root of 10. And that's okay. All right, square root of 5 minus the square root of 10. I can't do anything to simplify that. We are okay with having a radical in the numerator. We don't want it in the denominator. Of course, I could simplify this final answer by just doing square root of 10 minus square root of 5, right? Just multiply it both sides by that negative 1, okay? So that's what we're going to do. We're going to practice multiplying a denominator by its conjugate. Let's go on to some examples. All the way down. Keep going, keep going, keep going. Just want to see if I'm covering everything we need. Yeah, this is this lesson. That was it, okay? So we've already covered a bunch with monomial, so I'm not going to have you do 3 through 14. We've kind of already covered that. What I want you to do is do the odds, numbers 15 through 37. I'm going to do a few for you right now. So let's start with 15. 15 is this. We've got 1 over 3 plus the square root of 5. I want to rationalize that. So I'm going to multiply it by 3 minus the square root of 5 over itself. What do I get when I do that? Well, the top will stay the same, right? Because it's 1 times that. And the bottom, I'm going to get 9 minus 3 times the square root of 5. Of course, you don't have to write this out every time. Once you kind of get the gist of it, that the two middle terms will cancel, you don't have to write them. Square root of 5 times negative square root of 5 is minus 5, negative 5, okay? So we're going to write that like this. Of course, these two middle terms cancel, leaving me on the bottom with 9 minus 5. That's just 4. And up top, we had this. All right, there's your answer for number 15. Let's see, I'll have you do 17, 19, 21. A lot of these seem duplicative. Honestly, let's not do all of these. I just, well, you can do them all. They're pretty quick. Let's do 25. 25's got a variable in the denominator. Same process though. It's just slightly more challenging on your algebra skill to deal with variables as well as numerals and constants. But we're still going to multiply this by its conjugate, which is the square root of 5x plus 2. The square root of 5x plus 2. All right, so up top, we're going to distribute. The square root of 5x times the square root of 5x is just 5x. And the square root of 5x times 2 is 2 times the square root of 5x. 5x. Down below, we've got the conjugates now, right? Multiply the first two, we get 5x. The two middle of FOIL will cancel out, leaving me with minus 4 here. And that's it. There's nothing else I can do, okay? I cannot cancel out these 5x's. I can't do that because the plus and the minus here kind of couple those two terms up into a binomial. And we cannot cancel just parts of a binomial. So that's your answer. There's nothing else I can do there. All right? Okay. That was 25. Maybe I'll do one more. Um, let's do 35. Okay? 35. What happens when? Sorry, my whiteboard just froze for a second. 35 is this. 2 over the square root of x over, sorry, I don't know what's going on here. I might have to reload this. Nope, there we go. Okay, 2 over square root of x plus 2 over the square root of y. Um, I mean, what I would do here, first if we want to merge these into a single fraction, we could multiply each one by its respective denominator. So I'd multiply the first one by that, the second one by this, and then what we're going to get is a single fraction where we have 2 square root of y plus 2 square root of x all over the square root of xy. And now we can actually multiply by that denominator, top and bottom. And we'll get something like this. This is a good challenging problem to master your manipulation with radicals. The bottom's quite simple, right? xy. The top, right? We're going to get 2. I have a square root of y and a square root of y. That turns into a y. And then leaving me with a square root of x. And on the other one, um, I can extract the x from the radical symbol. So it kind of looks like that. And that's your simplified, rationalized fraction. Okay. So pause now, finish up odds numbers 15 through 37. I will, in my email, I'll send along the answer key with my work for those problems. And then after you that, continue on with this video. There is one more section we're going to do today, and that's solving radical equations. All right. When you see the word solve an equation, that means we are looking for the value that when I plug it into the variable, it makes that equation true. All right, so uh, the only difference with these equations now, there's a radical somewhere in the equation. Let's do this simple example together. All right, 2x minus 3, 2x minus 3 equals 5. All right, remember, algebra is really, when you're solving equations, it's really all about applying inverse operations. So the way we're going to solve this one is apply the inverse operation of this square root. What's the inverse of square rooting something? It's squaring it. We're going to square the left side of that equation. And of course, we can't square the left side of the equation without squaring the right side of the equation. Okay? All right, so when we square the left side of the equation, it really just gets rid of the radical, keeping the 2x minus 3. And then on the other side, 5 squared, that's 25. And now this is an algebra 1 problem. You would add 3 to both sides and then divide by 2. Now you get 14. Here's the thing, though. When you do this operation here, in certain situations, it will create an extraneous solution. An extraneous solution is a solution that actually doesn't work. You think it might, but it doesn't. So all that being said, all we have to do every time we solve a radical equation, you just have to check your answers because sometimes it won't work. And the way you check your answers, you just plug in what you got, 14, into the original equation. I'm plugging a 14 in for x as originally written. And then I'm going to do 2 times 28. 2 times 14 is 28 minus 3 is 25. And we can see right off the bat the square root of 25 is 5. So that one checks out. That is your answer. X equals 14. I want to show you an example where it doesn't work. And here's a good one right here. I'm going to walk you through this one. All right, so we have x minus the square root of 5 minus x equals 3. I don't want to square the left side of this equation yet, because if I squared the left side of this equation yet, I'd have to square that binomial. and it won't get rid of the radical. So the idea is you isolate the radical first. So we're not going to do that. Instead, we're going to move the x by subtracting x from both sides. And that's going to give us negative square root of 5 minus x equals 3 minus x. 3 minus x. At this stage, now we have the radical isolated. We can square root the left side. The fact that there's a negative sign in front, that's really like a negative 1 times that square root. It has no impact because guess what? We're squaring negative 1. Negative 1 times negative 1 is positive 1, so it will have no impact. Our result on the left side then is going to be 5 minus x. And of course, we have to square the left side as well. When we square the left side, that's a binomial, right? So instead of writing it like that, I could also write it like 3 minus x. And then we're going to FOIL out the right-hand side. And when we do that, we'll get 9 minus 3x minus another 3x, so that's minus 6x, plus x squared. Okay, this has turned into a quadratic equation. I showed you a glimpse of some quadratic equations last week, Friday. And I think what I taught you was we can solve this um, if we get everything and set it equal to 0 and then try and factor uh, that right side. So let's do that. I'm gonna subtract 5 from both sides and I'm gonna add x to both sides. And I'm going to rearrange the terms in standard order, so descending exponents. So this x squared is first. I'm adding a 1x to the negative 6x, so that's going to make that a negative 5x. And I'm subtracting a 5 from the 9 to give us 4. All right, so now we've got that. We learned how to factor this kind of trinomial, right? Two numbers that multiply to 4 but add to negative 5. That's 4 and 1, and they're both going to be negative, right? So the factored form of that trinomial is x minus 4 times x minus 1. Well, what will solve this equation? It's whatever is going to make the first factor 0 and whatever is going to make the second factor 0. Well, the first factor, if I plug in a 4, I get 0. So that's my first solution. Second one, it's positive 1. Notice here I have two equations. You might recall that if you have a quadratic equation, you can have up to two solutions. But because this started out as a radical equation, we have to check both of those answers. Let's go back and plug in one at a time, the 4 and the 1. So I'm going to plug in the 4 into the original equation, in which case I get this. 4 minus the square root of 5 minus 4 equals 3. All right, well, 5 minus 4 is the square root of 1, which of course is 1, and 4 minus 1 is indeed 3. So this solution works. X equals 4 works. What about x equals 1? In that case, we would have 1 minus the square root of 5 minus 1, determining whether or not that will result in in 3. And here we'll get 1 minus the square root of 4. Well, that's 1 minus 2. 1 minus 2 is not equal to 3. So right here, this is an extraneous value. X equals 1 does not work. All right, so our solution here would just be x equals 4. We disregard the solution that doesn't work. And that's what we're doing here in this lesson. So I'm going to scroll down. I'm going to assign to you some of these example problems to do. One second. My whiteboard just decided to shut down. And hold on, I may have to bring it back up. Let's do this. Whiteboards. Lesson 3. Share. Nope, that's not what I want to do. Okay, something's not working here. What's gonna happen here? Let me just da, 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 da. Let me stop sharing, cancel. One participant can share at a time. How did I do this before? Okay, can I share here? Share. I'm sorry about this, guys. Share. Stop share. Reshare. Here we go. Whiteboards. Existing whiteboards. Okay. Hopefully this brings us back to where we were. Yes. Good. Hopefully you can see this. Almost there. Examples, examples, examples. All right. A lot of problems on this one. Um, so I'm going to give you a lot of practice. Let's just do all the odd numbers. All right. So we're going to do, let's do the odds. Numbers 3 through 37. All right, I'll do a couple examples for you. Obviously, the simplest version here, number 3, square root of a equals 5. Square both sides. Square, square. When you square the left side, you get a. When you square the right side, you get 25. That's your answer. Check it mentally correct. That one works, right? Square root of 25 is 5. So some of these early problems, a little bit simple. Look at number 7. When you have a coefficient there, you can do one of two things. All right. You can divide both sides by 2 if you want first, or you can go ahead and square it. It doesn't matter because eventually if you square this, you'll just get 4b, right? Which then you'll divide by 4 in the next step. So you could have either divided by 2 at the initial step or divided by 4 at the next step. This is 64. If 4b is 64, divide 64 by 4 and you get 16, and that's b. All right, that one works out. Let's see, what else? If you get a problem like number 17, right, there's only one of those there. I'm not going to do this one, but I just want to point out, hey, what happens if you square both sides of number 17? Both radicals disappear. All right, and then you just have an algebra 1 equation left. So you guys can do that one on your own. I want to do one or two of these more challenging ones for you. So for instance, let's do 21 together. All right, 21. X plus 3 equals the square root of 1 minus 3x minus 3x. Square both sides. That's going to eliminate the radical on the left, sorry, on the right, and we'll have to FOIL on the left. Foiling x plus 3 squared is x squared plus 6x plus 9. That equals 1 minus 3x. Let's set this equation equal to 0. So I'm going to add 3x to the 6x, and I'm going to subtract 1, leaving me with this quadratic. The factored form of this, two numbers that multiply to 8 but add to 9 are 1 and 8. And then the two values that solve this equation are -1 and -8. Now we have to go back and check both of these. Especially with the quadratic, sometimes one of these might not work. Let's plug in -1 into the original equation, and we'll get this 1 minus 3 times -1. On the left side, we get 2. And on the right side, we get 3 times negative 1, but subtracting it, we actually get square root of 4. That's going to work out, right? 2 equals the square root of 4. So negative 1 works. Repeat the process with negative 8. And we get 1 minus 3 times negative 8. Here we have negative 5 equals the square root of 1 plus 25. This is not true, okay? Although negative 5 is a root of 25. You might recall whenever we use the radical symbol, we are looking for the positive root. So this is not a true equation, which means negative 8 is not a solution. Your only solution here is x equals 1. Let's do one more together, and then I'll send you on your way. Um, let's do one. 27 looks pretty challenging. Let's do 27 together. So 27 is this: x plus 4 times the square root of x equals 5. I can't square both sides yet uh, because the radical is not isolated. So let's subtract x. And when I do that, I get 5 minus x. Um, I can square this now. Let's go ahead and square this. We might get some fractions later on in this problem, but I'm going to go ahead and square this now. Let's see what we get. 4 squared is 16. Square root of x squared is just x equals, we get 25 minus, right? I'm really just doing this, 5 minus x, right? 25 minus 5x minus another 5x is minus 10x plus x squared. Okay, no fractions. This one actually works out pretty good. I'm just gonna subtract 16x from the 10x on the other side, and then just rearrange the terms so that they're in descending exponent order. Let's go ahead and factor this one. Two numbers that multiply to 25, but add to negative 26 are negative 25 and negative 1. Our two potential solutions here are positive 25 and positive 1. We've got to go ahead and check that. Let's go ahead and check 25 first. Going back to the original equation, we have 25 plus 4 times the square root of 25 equals 5, right? Plugging that in. 25 plus 4 times 5. This is definitely not going to equal 5, right? This is actually 45 equals 5. That is not a true statement. So 25 does not work. What else? 1 plus 4 times the square root of 1. Does that equal 5? Well, yes, square root of 1 is 1. So this one definitely checks out. Our answer is x equals 1. There are some situations where if you result in a quadratic, both equations will work. So don't just stop if you think you've identified, oh, the one that doesn't work. Just check both of them. If anything, it's a good little extra practice for our algebra brains to grow and develop. All right, go ahead and finish odds number 3 through 37, and that's it for this lesson. All right, I'll send a lesson 4 probably tomorrow and on Saturday, which is Saturday, and we'll get started with quadratics, and then on Monday we'll keep going with quadratics. All right, enjoy.